Hello, everyone. We're going to be doing some winter weather forecasts. It's kind of cold out here when I'm doing this lecture. I have a fan on just because it might be summer going on here, but this is what's outside my house in one of the big snow events a couple of years ago, so I thought I would continue that. Let's go ahead and share the screen. Here we go. And just so you know, this is going to be, I think on the syllabus, it may have been one or two different lectures. We're going to do is one lecture. And it's not even going to be that long. I'm just going to kind of give in some highlights here. And the reason for that is I've got a lot of videos for you to watch. So here's 4 videos that I want you to definitely look at, take notes on, and then write some little comments on it, because there's some important things in here. You might get this on a test. Not really take notes, just watch them closely. But I do want you to take notes on these 2. Those are more from the Weather Channel. Those are really cool explanations of a couple of things, so make sure you know that. And then for fun, I added these videos here. They're kind of hilarious, actually. There's one guy who gets really angry, can't get his car out of a parking spot, and it's funny. And then there's another really cool one in Seattle, looking at the way cars cannot ride on ice, just so you know that. So here's the lecture for winter weather and fog. Do a good job on this. So we're going to start out with looking at some winter text. Now, obviously, this is the middle of summer that I'm doing this lecture, but I wanted to tell you about a couple things that we do have in our products. Remember that the National Weather Service all winter comes from the local office. So any watch, warning, or advisory is a local office event. Okay, and we've already gone through a lot of them with ice storm warnings and blizzard warnings. Here's what you need to know about blizzard. Blizzard is more about visibility restriction and also wind speed. And that's what's reducing visibility. So you can have a ground blizzard where it's not even precipitating snow, it's just blowing snow. Just keep that in mind. And when we get to winter products, I think it's pretty self-explanatory on a lot of these things, but I wanted to say a couple of things that we can look at. We look at something called snow depth, and this actually can be determined in the United States. I like this one. Obviously, a little bit of snow still in the mountains in June, but if we go back in a time, you'll see that we had areas, here's April 17th, where we had a good snowfall, and this just gives you how much snow is on the ground. But what's important, remember, in terms of like flooding, it's not just that there's snow, but there's water in the snow. Now, we usually say about 10 inches of snow can melt down to about 1 inch of water. And that idea of melting into a liquid equivalent is something that they do when they're taking measurements for this thing called CoCoRaHS. So here's CoCoRaHS. And again, this is something that you need to know. Community Collaborative Rain, Hail, and Snow Network. These are individual people who take measurements of how much rain, how much snow every day of the year. They get up every morning and do this. These are volunteers who do this. And they do have a way of taking snow, and they capture the snow, and then they melt it down, and that becomes this snow water equivalent. So usually it's 10 inches of snow, but sometimes that compacts. Sometimes it's that really heavy wet snow, and then you have like 5 inches of snow as 1 inch of rain. Sometimes it's really cold, you get really fluffy snow. Then you're talking about 20 inches of snow could be melted down into 1 inch of rain. So it depends. And CoCoRaHS helps measure that. So when I look at snow water equivalent, you can look somewhere in here toward the end of spring, and notice up here in the UP of Michigan, maybe upper Maine, you were at about 6 to 20 inches of snow water equivalent. So that tells you how much, or actually, that tells me how much water is really in there. And then if it melted rapidly, maybe it was a rainstorm and a quick warm-up, you're adding that additional water to the rainfall, and that's what could lead to flooding. Now, there is the Weather Prediction Center that helps do some national guidance, the WPC, and they'll talk about probabilities of snow more than 4, 8, 12 inches, or ice accumulations. Remember, the key ice accumulation is 1/4 of an inch. So we have the probabilities there. Those are pretty simple products coming out of the Weather Prediction Center to help with that, along with QPF. But it's the local office that's going to do the weather forecasts that deal with winter weather advisories, watches, and warnings. Okay, now just to give you some idea, the big one, the really deadly one, is an ice storm. And you're watching that video from the Weather Channel, which I think is great about ice storm. And I just did an ice storm in Paducah, Kentucky in 2009. That's kind of the belt of really big ice. And here we are looking at some of the pictures of ice storm and how it affected everything, okay? So in this scenario, power lines come down, tree branches come down, it looks like a tornado hits. Roads become impassable. Here's an example, almost 2 inches of ice covering the trees. And when you're about a half an inch, telephone lines are gonna come down. So just crazy, you can't pass through roads, the roads are ice covered. So not many people die of a primary cause, right? The ice is not killing them. I mean, maybe it knocks down a tree that kills them, and that happens. But let's imagine that somebody has a heart attack and the roads are blocked and nobody can get to them. That's an example of a secondary event. That was on one of our worksheets. And I know that a lot of people were not understanding what that meant. A primary event is when you get the weather itself killing you. The secondary event is when something else kills you, but weather contributed to a problem. So one of the questions on was, does the flooding of a hurricane, when it kills somebody, is that a primary or secondary? And that's actually primary because it is the hurricane generating the rain. Just like a storm surge may kill people, rain is killing people. They are dying in the flood. Now, a secondary effect on a winter event might be snow shoveling. Heavy, wet snow, people are out there exerting a lot of effort. The snow didn't fall on them and trap them and kill them, but in trying to remove it, they had a heart attack and died. That's a secondary effect. Okay, so just kind of keep that in mind as you go through this course. Okay, so that's kind of talking about the winter. Again, I have a lot of videos on winter and how bad it is. And we call this fog and travel along with winter is because travel is really the biggest problem. You know how we said that a warning is imminent and it's life-threatening? An advisory is imminent, but not usually life-threatening. The biggest exception to that might be some freezing drizzle or light freezing rain advisory. What happens is people tend to go way too fast because it's only an advisory. I think this is a problem in the system. And so what happens is people drive fast, hit black ice, that freezing rain that freezes on contact. By the way, we're going to get this in the precipitation type forecasting coming up. But you hit that ice and you don't know it's bad and you are going too fast and you can't stop and you hit somebody, you crash. That could be really deadly. Freezing drizzle. Sometimes you get a morning advisory. We had this at COD. Freezing drizzle doesn't even accumulate. It's less than a hundredth of an inch of rain, just enough to make it icy, and people are crashing all over the place. And it took people 2 to 3 hours to get into COD in their classes. It was a mess of a situation. And that's where the warning of an ice storm warning could be really more effective because people aren't going to go out. It's an ice storm warning. I know that I can't drive fast. Or if it's really bad snow, I'm not driving as fast. But when it's freezing drizzle, people are often not aware of how dangerous it can be. So that's something to keep in mind, that a freezing drizzle advisory sometimes is more deadly than an ice storm warning in terms of actual primary impact deaths. Okay, now the last thing that we want to talk about today is fog. So we talked about the Fog Bowl, and that's kind of an amazing game. I remember that very well, watching it, and you couldn't see anything on the field. It was hilarious. Yay, Bears beat the Philadelphia Eagles. So keep those teams in mind, okay? So fog is really a cloud at ground level. So when you have fog, you are looking at, excuse me, you are looking at a cloud where the relative humidity is really close to 100%, if not 100%. When relative humidity gets up there over 75 to 80%, you might start getting a reduction of visibility. At an airport, this is super important, so that you might say mist if you can only see a couple of miles. But when you get fog, you start dropping down to less than a kilometer, or less than about a half a mile. And then we start really getting big impacts on visibility. And as you know, if you can't see and you're driving, well, there's a problem. On one of the worksheets, I asked you, well, what do you do in that situation? Number one thing is do not put in your brakes. because your high beams reflect too much light and you lose visibility. So you need to keep them low so that you're illuminating the road. You oftentimes will have fog lights, which are yellow lights, which are really low in your car. And yellow is a color that cuts through fog more than any other color. So if you've got yellow lights, that's sometimes easier to see than white lights. The biggest problem with fog, and this is one of the things that we try to bring across to you, is it's fog, just like snow, is a dangerous place, dangerous thing to drive in. And the reason is, do you go fast or do you go slow? And most people say, well, they hit a bank of really heavy fog. Slow down, which is great. But what about the guy behind you? If the guy behind you is too fast, they're going to hit you. If you're too fast, you don't have time to react. It's just a no-win situation. So in my opinion, you want to keep a nice, really far distance. Give yourself about a middle ground speed. Keep your low beams on, maybe put on your hazards in a really bad situation, but really avoid driving in these high restricted visibilities. Now keep in mind that restriction to visibilities works for aviation quite a bit. There's some aviation work that I'd like you to do. And there's also for boating. So any commerce, anything that's moving shipments has to deal with visibility restrictions. Okay, so we're going to talk about fog, and I said look at the Wikipedia article for fog, and it tells you a little bit about what it is. It's fog is really when its relative humidity is near 100%. A lot of times it produces drizzle, and I think this is important that you keep drizzle in mind because we're going to talk about this in precipitation type forecasting. So drizzle means you're not getting ice, so you can have actually freezing fog, temperatures below freezing. The cloud itself is still liquid water. We'll get into that in more detail later. So the types of fog, let's just deal with this way. The first and the most common type of fog is radiation fog, and I'm really going to kind of extend that to ground fog. I'm going to say that they're the same thing. So radiation fog is the most common type of fog, and basically what's happening is the ground is losing energy to space through radiation. The temperature goes down at night, and when the temperature goes down, W sub S goes down, and the relative humidity goes up. Eventually you reach saturation and you start to develop fog. When we talk about the really thick wintertime long night fogs, they're going to be radiation fog. So what I want you to think about this is that there's radiational cooling is dropping the temperature to the dew point. And when that happens, you're going to get fog. Now advection, I don't know if you remember this, advection is the horizontal movement of air. So a lot of times we have warm, moist air over cool surfaces, like cold water or cold snowpack. So what I want you to think about advection is you start to cool the air because you have horizontal motion. And that's what advection fog is. So San Francisco is advection fog. If you hear people say fog rolls in, that's an advection fog. In the fog bowl, fog came in from the lake. It came over the stadium with some of their descriptions. That coming over is an idea of advection. Okay? Now, another type of fog is this thing called evaporation or steam fog. Steam fog, now that's kind of interesting. You basically have mixing of air that's from water, which is fairly warm, over very cold air above it. So one of the things that I want you to think about is another name for this is called Arctic sea smoke. That's what steam fog is. So if you ever see something that maybe looks like this, where we see the steam coming off of a lake, sometimes on a hot day when the pavement's really hot and it rains, the rain's warm, and then it starts mixing and you get this light fog or steam coming off of this. So steam, the key idea of steam is mixing of the air causes saturation. Now, this is not going to typically be super thick, but it is a type of fog. So steam fog or evaporation fog or Arctic sea smoke. And spell Arctic correctly, please. That's what that is going to be. So mixing is the key process for that. Now, frontal fog, they're talking about maybe if it's raining a lot. Obviously, when it rains a lot, the rain's evaporating. There's cooling. You're adding vapor and you're taking away a capacity. Brings the relative humidity to 100%. Talked about freezing fog, and just so you know, you've already got that freezing fog, which you did in that little video. And then the other thing here is this one upslope. And a lot of times when air is going up a mountain, we say forms a cloud, it reaches the LCL. What does LCL stand for? You should know that. But upslope just means that the air is going up and it's cooling. And because it's cooling, W sub S is decreasing and the relative humidity is going up. So really when you get fog along a mountainside, it's really upslope. What are the key words right here? Adiabatic cooling. So that's really the most important concept, is that upslope fog comes from adiabatic cooling. So if you attach those phrases to each type of fog that I've talked about, you should be fine. The key thing is just a restriction to visibility. It's really bad for airplanes. If you're going to shut down an airport, fog is probably going to be the #1 reason. And there's a module on MedEd that says fog and low stratus, really low cloud. So the ceiling, which you'll define, and the visibility. Okay, and just kind of cool. So there's your visibility effects. There's some cool things that you can look at if you want to, but that's really what I want to deal with in terms of fog. So we have fog, we have Arctic sea smoke, we'll get rid of that. We have CoCoRaHS, make sure you know that term. And then we talk about our winter products. Remember, for fog, it's a dense fog advisory. There are no fog watches and warnings, at least not yet. Okay? And I think with that in mind, we can stop sharing, and I hope you have a great day. Enjoy those movies if you haven't done so already, and good luck with this lecture. See you next time.